Here there. Today we are going to solve another LeetCode problem named remove end node from end of list. Medium level, and it goes like this. Given the head of linked list, remove the end node from the end of the list and return its head. There are some examples here, like list of 5 elements and the second node from the end is being removed. There are some constraints. The most important one is that the size of the list is greater or equal to 1, which means that it is not empty. All right, so let's try to solve this issue. As you could understand, to remove any element from the list, first we need to find the node standing in front of it and just reroute its next pointer to go over the node which we are trying to remove. And to reach this node, we need to go step by step from the head, and the amount of steps actually is equal to the size of the list subtracted by n. Unfortunately, we don't know the size of the list, and this is the main issue with this task. So instead, let's do something more interesting. Let's set up 2 pointers. One pointer, the left side pointer, is going to point to the head of the list. The right side pointer would point to some element or some node in the list on the distance of n from the head. And after that, we are going to move them together to the step when the right side pointer reaches the end. At this step, the left side pointer would point to the node on the distance of n from the end. And this is exactly how we are going to find this element to be rerouted. All right, so let's create some code. And first of all, I would like to unwrap the head so that we would avoid any work with the optional values. And the next step would be setting up the right side pointer. Initially, it's going to point to the head, and we need to do n steps from the head to set it up correctly. So let's create some kind of distance counter and count it up to the end. And at each iteration of this loop, we would like to get the next pointer from the right pointer next. And if it is there, then we could just reset the right pointer to the next pointer. All right. So after this loop, potentially we have our right pointer set up correctly. The only case when it wouldn't be there is when the n is equal to the size of the list. In this case, the last step of the loop would fail because the last node in the list doesn't have any next node. As you could understand, the distance counter is not going to reach n at this case, so we could actually identify it and handle it using the guard. So if the n is equal to the size of the list, it means actually that we need to drop the head, we need to drop the first element from the list. So let's just return the head next as the result of this method. All right, now let's set up the left side pointer to the head. And finally, we could start moving those pointers both together. So the left side, the next left pointer we are going to get from the left pointer next, and the next right pointer we are going to get from the right pointer next. And at each iteration of this loop, we are going to just reset the left pointer to the next left pointer and right pointer to the next right pointer. All right. So when this loop is terminated, the right side pointer points to the last element in the list. And the left side pointer points to a node on a distance of n from the last one, which means that it is an n+1 node from the end of the list, the node which we are actually trying to reroute. So let's modify its next pointer and point it to the node one step ahead. And after that, we are able to just return the head and the code is done. Let's check for any compilation issues. Nothing here. And finally, let's submit the solution. Nice. So as you can see, it was executed on all of the test cases in technically 0 milliseconds. Basically, the execution time stands somewhere on the edge of the threshold, and that's why it beats 100% of other submissions. And that's it for today. If you'd like to see me solving other LeetCode problems, then put your request to the comments section. See you next time. Cheers.